So, again, let me take another example so that you understand this better. Let's say patient Bala has 5 CT scans. And if you put 4 CT scans in the training set and 1 CT scan in the test set, that's like a cheating because AI learns Bala's anatomy, not the disease. Now you must split by patient ID. That's what I was trying to emphasize, so that images are different for the different people. If Bala is in the training, all of Bala's data stays in the training. It cannot exist in the test set. It's like showing a student that exam questions before the finals. So from the context, I just want to ask you all one question. Who has caught a student doing this in a project? I hope someone would have caught. So it's almost like if people are cheating, you'll be definitely able to caught. So similarly, training versus testing is something you need to make it much more different data sets so that it will really play a very important role in the judgment. So another important dimension is about the evaluation metrics in the foundation elements, what you're trying to really look at. So this is very, very critical because when you look at the evaluation metrics, you always feel that accuracy is a lie. If I built a rare disease detector for a disease that affects 1% of people and my model just says you are healthy to everyone, I'm 99% accurate, but I'm also 100% useless. So we need a better metrics. So the 3 important metrics I wanted to emphasize is sensitivity, that is a recall rate, specificity, and precision. Sensitivity always talks about did we catch all the sick people? High sensitivity is very, very crucial for screening like cancer. We don't want to miss anyone. False negatives are dangerous. Second is specificity. Did we correctly identify the healthy people? High specificity prevents scaring people, healthy people. It's like false positives. Third important metric is precision. When the machine beeps, it is actually a problem. In ICUs, alarms beep constantly. If precision is low, nurses get alarms fatigue and stop listening. And that is even more dangerous. So we need to have this better metrics which can give you a much more deeper understanding of all these particular elements so that you understand the model performance in the right context and you'll be able to make the decisions better. Today, AI projects become clinically useless because they don't have the right metrics in place. Because we go and run behind the accuracy, which is very, very seductive, but it is very dangerous also. So that's the reason I was emphasizing all these important elements. Once you understand, you'll be able to make a better impact. So if you take uh, performance across the thresholds, robust, which are very big, which will help you to create a robust imbalance. Uh, there's a method called AUROC, which will help you in doing this. So one thing you should ask currently when you're trying to teach your students, which is worse, false negative or false positive? We heard in the context of specificity and the precision, false negatives and positives, both are coming. But you should ask, which is worse? The answer completely depends on the disease under which you are trying to operate. So that you will be able to clearly give the view, the sensitivity, specificity, and also the precision. All 3 important metrics, why it matters to the context of the healthcare. Let me take a move to the some of the important early disease detections on the diabetes risk so that you understand these things better. And okay, I have 28 more minutes, I believe. We'll try to address these things as fast as possible. And so if you take the early detection of this diabetes, let's see. The data here is completely structured. You take age, you take BMI, you take glucose levels. It's a spreadsheet problem. So we choose a simple supervised learning model like logistic regression. The goal is a risk score, what you try to really look at. If I say Bala has a 84% chance of diabetes in 5 years, the clinical action is not surgery, it's a lifestyle counseling. Since the intervention is low cost advice, we can afford some false positives. We prioritize sensitivity, let's flag everyone at risk. So look at that particular element, what you're trying to really do in the context of the early disease detection. So the clinical problem when you're trying to emphasize on that is very, very simple. Identify patients at high risk of type 2 diabetes early. The data can be structured And you can really try to recommend the lifestyle factors based on their age, BMI, family history, and glucose levels. And you can use the supervised learning methods covering with a logistic regression or random forest methods, or which is much more interpretable and trusted, so that your output is not a diagnosis, but your risk score is also comparatively can be made it as a 80 odd percent. What happened next is very, very critical because AI does not prescribe anything for you. It triggers a clinical action. As I mentioned in the context of diabetes, it triggers a counseling, it triggers a lifestyle changes, it triggers more frequent screening every 3 months. You find out your HbA1c. And that will really help us to correlate and identify the pattern behavior. So, in the context of this early detect diseases, which metrics matter more here? Sensitivity or specificity? This is one question you should ask your students so that they can prompt it. Sensitivity matters in the context here because it is a missing a diabetic patient is worse than a false alarm. So you need to really catch those particular things because this particular case shows the ideal role of AI, which can give you the early warning, involves the human decisions, looking into the better outcomes with the right counseling and the lifestyle changes, so that you significantly see the kind of a behavioral pattern changes to the right level. Now let's take a question onto the radiology because this is often used, one of the most heavily used department in the context of AI. So in the radiology department, when you're trying to look at the data is completely unstructured because it's all in images. We need deep learning convolutional neural networks, as we saw that principle. Radiologist gets tired looking into these images of hundreds of scans in a day. So there's a lot of fatigue in their memory also. So AI acts like a second pair of eyes. It draws a box and says, "Hey doc, check this particular spot where I'm seeing some abnormality." And try to notice this particular workflow. The AI does not diagnose, it highlights. The human validates, and this is an augmented intelligence, not artificial intelligence. So when you understand where AI is trying to augment the work, you'll be able to appreciate the kind of a level of involvement really helping you. So the fear of replacing the radiologist is never a question. It's always augmenting radiologists so they can really move away from the mental fatigue and focus on some of the critical identified abnormalities where they can really interpret and give the guidance. So radiologists today are dealing with high volume CT scans. Time pressure is always there because the reports need to be submitted to the different doctors for the quicker analysis. So the fatigue related misses, especially for small nodules, can be really create a bigger impact. In India, today the problem is even more acute due to radiologist to patient ratio constraints, especially in the tier 2 and tier 3 cities. The number of patients and the number of radiologists is abnormally low. So when we look into the phase one, the data, we are dealing with unstructured high dimensional data like 3D, DICOM, CT scans, thousands of slices for the patients. Expert radiologists requires a lot of annotations to be given. This truly tells us something important as an educators. This is not a classical ML problem. This is truly a deep learning computer vision problem. And in phase two, the model uses CNN-based architectures where often you UNet or 3D CNNs. But notice the model is logic carefully. The network is not learning cancer. It is learning hierarchical visual patterns like edge, shapes, textures that statistically correlate with nodules. The output is not a diagnosis. It is trying to give you a kind of a guidance, and that guidance will help you to interpret it better. It is highlighted as a region of interest with a confidence score, and you inspect that particular region to identify it as a smaller nodule or higher nodule, larger nodule. And that can help you to flag it and try to make a deeper analysis, which can help you to get the clinical action done in this phase 3. So if you are trying to look in from the AI angle, it pre-reads the scan, flags the suspicious regions, prioritizes the urgent cases. The radiologist it will help the radiologist in validating or rejecting the findings, makes the final report, and assumes full clinical responsibility. So I just want you to emphasize the fact to your students that AI becomes a second pair of eyes, not a replacement brain. AI becomes a second pair of eyes, not a replacement brain. Let's take another important case study in the context. ICU monitoring, sepsis early warning, very, very critical healthcare related symptom. Always you try to emphasize the fact why in this particular case study the time matters more than the snapshots in the healthcare, because in every patient in healthcare is very, very critically and need to be focused and immediately addressed. Sepsis, when you're trying to do it, does not arrive suddenly. It evolves silently over hours. The clinical goal here is to ambitious but life-saving decisions can be happening. Detecting the sepsis 6 to 12 hours before visible deterioration is a critical need to save the patient. You need to really monitor the heart rate trends, BP trends, temperature curves, SpO2 levels, WBC norms, and also the lactate levels. Individually, none of this may look alarming at the beginning, but the patterns of increasing levels or the decreasing levels can really help you to make the decisions better. A single heart rate of 90% is not dangerous, but a heart rate rising to 70, from 70 to 90 over 2 hours while BP drops in is a complete red flag. That correlations and analogy is very, very critical for you to make a call. This is where the phase 2 of uses temporal models like RNNs, long short-term memories, increasingly the opportunity to leverage transformers wherever it is needed. These models don't just use values, they really remember the trajectories of the patterns. The output is not sepsis, yes or no, it is a risk alert which gives you a kind of a right attention to be given for making the calls. High probability of sepsis within 6 hours. That is what we are trying to indicate with these particular models, so that there is a life-saving opportunity gets triggered. Phase 3 is where ethics and responsibility can truly come in. The alert does not replace ICU judgment at all. It buys time. Early antibiotics can be given, closer monitoring can be done, prepared interventions can be offered. So, as a faculty, you need to give this kind of an examples to your students so that they understand the results much better and deeper. Ask students why accuracy alone is meaningless in this case. The real value is early warning, not perfect prediction. Remember, real value is in the early warning, not perfect prediction. As long as you do that, we are going to make a bigger and bigger impact. So we need time series models like RNNs, LSTMs. The model can watch the movie of the patient's vitals, not just a photo. It predicts the crash before it happens, so doctors can enter or start antibiotics earlier, very, very early. So as I move on to the one of the important element, foundational element, explainability and interpretability. Not many people teach about it, but it is important that you understand. Because in healthcare, explainability is key for any kind of a model to successfully deploy by the doctors and leverage it. If a model cannot explain, God, doctors can never use that model. So explainability and interpretability is a critical important element. This chart makes a very philosophical turning point in this entire session, to be very honest. Up to now, we have discussed what AI can do. Now we can discuss whether we should trust it or not. Deep learning models, when you're trying to take, they're often called black boxes, and that's not entirely unfair. Clinicians will not and should not trust a model that says cancer yes without explaining why. Without explanation, without interpretation, doctors can never take any model for granted. Explainability matters for three important reasons. First, it establishes a clinical trust. Doctors must ensure that the model is focusing on meaningful anatomy, not artifacts. Second, patient safety. If a model is wrong, we just understand how it failed. The third important thing is regulation. Globally and increasingly in the India, if you are trying to lake, regulators expect accountability for automated decisions. So explainability AI techniques helps bridge this entire gaps, regulatory gaps, safety gaps, and the clinical trust gaps. This tells us which features contributed how much. For images like GradCam, attention maps, this show where the model was really looking at. And the true golden rule is I strongly encourage all the faculty members to emphasize this in your classrooms. If you can't explain, if you can't explain the model, don't deploy it. If you can't explain it, don't deploy it. So make explanation artifacts mandatory in the student projects, not optional. As long as you do, I think we are building the right future in this context. So if you are trying to take techniques like GradCam for images and or SHAP values, SHAP values, look at the lung scan, the heat map shows where the AI is looking. If the AI is looking at the patient's shoulder bone to diagnose lung cancer, we know it's a broken model. Explainability builds that kind of a trust. Again, emphasize that golden rule. If you can't explain it, don't deploy it. As I say about explainability and interpretability, there is another foundation things which you need to be really looking at: bias and fairness in healthcare AI. This is beautifully uh, every professional need to be really looking at it today. Many of these models are very biased and unfair, and this particular chart addresses one of the most uncomfortable but necessary topics. AI does not create bias. AI amplifies existing bias. Healthcare data truly reflects on the historical realities, unequal access, underrepresentation of the data, socioeconomic disparities can all result in the bias. If certain populations are underrepresented in data, the model will underperform for them. A classic example, if you take in the skin cancer detection models, performing worse on darker skin tones because darker skin tones data sets were never given for the model to train. In the Indian context, bias can also emerge from urban-centric data sets comparing to the rural sector, private hospital dominance comparing to the government hospitals, language and document variations. This is a true reflection how the contextual things will matter. Bias has a very real clinical consequences. When you have the data set which is biased, you will miss diagnosis, you will have reduced quality of care, you have a reduced loss of trust. And in this context, mitigation is not a one-time fix. It requires diverse data sets, fairness-aware evaluations, continuous monitoring which is required. And as a faculty, you need to emphasize important fact. You should introduce a fairness checklist in project rubrics for the students. Ethics must be graded, not just discussed. So you should say that your models need to be explainable, your models need to be ethically responsible, and that's how you try to grade the projects with higher ratings, which offers these things. I hope you are able to understand, follow. So one of the famous example happened in the bias and fairness is a skin cancer detection algorithm trained mostly on the light-skinned patients. It performed terribly in the dark-skinned patients. This was not a technical bug, it's a health equity issue. As educators, you should really teach fair AI and accurate, not just accurate AI. Remember that. And another important element, what you need to be really understanding the fact, probably we might have addressed these things in many other areas also, human in the loop. This is very profound uh, concept which you need to really summarize because the human in the loop is like a ethical backbone of the entire course. AI is not an autonomous actor in healthcare. It is part of a workflow. So optimal workflow looks like this. Means if you try to take the model proposes, it flags risks or suggestive funding, the clinician reviews, and the step two, like context, history, intuition, responsibility, comes into the overall play. And the third step is about decision and action. So only humans can consent and explain and be accountable. The step four is all about the continuous learning where feedback improves the system over the time. This loop ensures safety, accountability, and trust. So one of the important activity I would say you should really look at is give the students an AI output and ask them to decide whether to accept, reject, or modify it with the right justification. When you do that, they'll be able to do that, act like a feedback loop and improve that particular model and optimize these things to a greater level. So a human in the loop can bring speed and scale. It can read 1,000 X-rays in a minute, but human brings wisdom and context to it. Understanding that the patient is anxious or has a complex family history the AI does not know, together they can achieve better outcomes than either alone. So the future is not AI replacing doctors. It's a partnership which is really evolving together with a regular cadence. Now, one of the finer important section in the healthcare context we need to be understanding is regulatory and the clinical validation. You cannot ignore this particular element because this is a very important thing because this slide reminds on that healthcare AI is not a hackathon project. Going from research to real world use requires a lot of rigor. AI systems in healthcare are classified as a software as a medical device, SMAD. This involves regulatory approval, clinical validation, documentation, and the traceability. Without these three elements, you cannot deploy any healthcare models. Performance on the second important thing is performance on retrospective data is not enough. Models must be tested thoroughly with the across the prospects, across the sites, across the populations. And in the post-market surveillance context, once deployed models must also be monitored for the performance drift, data drift, model drift, and safety events. So very important things is because there is a change in the data set, change in the model behavior, change in the performance can be resulted. You should ask the students in the class to create a simple model card documenting intended use, limitations, and ethical risks. And this can really bring a lot of regulatory understanding and it helps them to think really early. This is a very important element what you need to really describe because we need to teach students about the FDA life cycle. Clinical validation is not just running a test script, it's a clinical trust what you want to clinical trial what you want to really establish. It takes years. This reality check is important for engineering students who are used to the move fast, break things mindset. Is in medicine, if you break things, people die. That's a consequence they need to really getting operated and you need to really work hard. So as we progressively move, I just want to also bring some important misconceptions under which we are currently operating. You need to be having an understanding and a view of the common misconceptions. So let's look at some of the things. A myth is today AI will replace doctors, but reality is AI handles routine tasks, doctors handle complexity and empathy. There's also a myth focusing on more data is always better, but reality is it's clean, representative data beats massive noisy data sets. The myth is also deep learning is always the best solution. Simple. The reality is simple interpretable models are often safer and sufficient. So you need to understand when to use what. Myth is AI is objective. No. Reality is AI inherits human and systematic bias. Myth is AI is not just a technical challenge. Reality is it is a socio-technology technical challenge involving trust, workflow, ethics, and regulations. So you should poll the students on these myths and the start the course so that really helps them to understand why this particular misconceptions really need to really look at it. So specifically speaking, we always emphasize that AI will replace doctors. I'm really telling that AI handles the boring stuff so doctors can be doctors, truly doctors. More data is better, you think, but better data is better. It's not about more data, it's about better data. I would take 100 clean records than over 1,000 messy ones one day. We always say deep learning is always the answer. No, sometimes simple regression models can also be safer, faster, and easier to explain. These are some of the candid examples which can really help you. As I coming close to the foundational learning, I want to emphasize some of the teaching strategies for you. If you can really apply this particular teaching strategies as the faculties which you're training, you'll be able to make a much more deeper and profound impact to your students. And this chart is more about educators. And you can start with the clinical problems, not the algorithms. Students can engage when they receive the relevance of it, why they are learning. You can prioritize visual intuitions, diagrams can explain, and before the equations come in. You can begin with the interpretable models. Confidence grows before the complexity arrives. You can encourage interdisciplinary collaborations. Healthcare AI is never about a solo discipline, it's interdisciplinary functions where the correlations really matter. And more frequently integrate ethics everywhere. Make them more responsive, make the models more trustworthy. No, not as one better, but as thread. So when we produce responsible innovators, not just the coders, and this is very critical. And when you follow that, starting with the clinical problem, establishing the visual intuition, focusing on the interdisciplinary teams, I believe we are going to bring a pair-based CS student with a bio student. Watch them struggle to understand each other's vocabulary. That is the most valuable lesson that they will learn when they work with a bio student and CS student when they pair up and work on the things together. Because technology and context and uh, anatomy of that particular knowledge is very, very critical. If you don't have the ontology of that understanding of that subject, people will have a challenge. In the classroom, I believe you should really focus and provide that kind of a guidance with a set of activities. I believe you will be doing it. These activities can transform passive learning into a very, very active thinking. Classification exercises can focus teachers into students how to map problems to the methods. You can bring in the critical exercises to build skepticism and the judgment. You can focus on data strategy, which is helping you to design, build systems thinking. And you can also have a healthy debates in healthcare, which really happens on one. The only trade-offs happen. There is no correct or answer because the context matters. So the goal is not to have the perfect models. The goal is to have a better decisions. As you try to do that, you are not teaching AI. You are teaching how intelligence should be orchestrated and responsibly handled with respect to the medicine. And that is far more important task as a faculty to the students. So when you do that with consistency, I believe this active learning strategies can really play a very important role. One of the thing as a task, you can say data audit, give them a data set and ask who is missing. You can also critique the model, give them a model with 99% accuracy and have a very terrible recall. Make them argue why it's bad model for cancer. So get them thinking critically, not just coding blindly. As you do that, you will be able to play a very important role in this entire journey. So a lot of courses, modules available, and there are tools and frameworks, journals, conferences and communities. All these things, resources are available in the context. You should be able to leverage that and use that as much as possible. So, as I'm approaching this session to the end. Uh, where do we go from here? So, you need to really curate learning pathway designed specifically for the faculty who want to teach AI in healthcare responsibly. So, some of the things I always advise faculty to choose the courses that are problem driven and not rule driven. Courses like AI for medicine, applied deep learning programs, focus on why, when, and not just how. So similarly, the medical data sets, there is a government of India published a lot of medical data sets in the Indian context. You can leverage both from urban and rural data sets. And Gov data is where you can find all these models. And healthcare education can really rely only on the toy data sets. Data sets like ICU records, chest x-rays, physiological signals expose students to real noise, missing data, ethical constraints. And that is where students can learn with the humility. Then comes tools and frameworks. And my strong recommendation to you all is remove friction wherever possible. So you can use cloud-based notebooks, reduce the setup pain so that allow the students to focus on the concepts, not on the installations. Finally, use journals and IEEE journals in the communities so that you can encourage faculty and students to read one paper in a month, not 10 at one go. So depth matters more than the breadth, I would say, so that your continued learning can be transitioned in a right path. As I say, you don't need to invent everything from the scratch. Use Google Colab as your best friend. Zero setup, not just coding in the you just code in the browser. Data sets like MIC for ICU data or NIH just X-ray are free. They are like a gold standards. Use them. As I say, you also need to have an understanding how the future is getting unfolded, where AI, ML data is heading. So I believe in the first session, you got some kind of an understanding how this future is getting unfolded. And the future of AI in healthcare is not about single breakthrough. It's about the convergence. And you try to talk about the multimodal AI is about integration. Patients are not images or lab values or nodes. They are all of them together. They're collected together. Future models will reason across the modalities, closer to how clinicians really, really think. And federated learning addresses a very real constraint that is about the data privacy, what you need to be aware of. Instead of moving patient data, we move models. This is especially relevant in the countries like India, where data sharing regulations and institutional boundaries are very, very strong. Edge AI brings intelligence closer to the patient. In fact, today I was reading one of the article from Arvind Srinivasan, the CEO of Perplexity. He was saying that the global data centers power will be diminished because most of the data will be processed and decisions will be made at the edge devices. It could be your watches, your wearables, could be the data sets which are local processed, gets processed. Edge data centers or edge devices will be very, very prominent in that context. The portable scanners, wearables as a point of care devices. This completely reduces the latency and increases the access in remote settings. What does that mean? Your edge devices will have the capability to run the large language models. Generative AI is not just about replacing clinicians, to be very honest, it is about augmentation because they will help you to draft clinical notes, synthesize reports, generate anonymous data for research. Explainable AI, we learned, continues to grow in importance. The future is not just predictive, it is reasoning. And finally, the personalized medicines. We move from population averages to individual pathways. As a faculty, I would emphasize the fact that you should ask students to pick one of these trends and find a recent clinical paper. This builds research literacy also for them and also builds a future readiness. This is very, very critical as part of your journey. When you do that with consistency, you will be able to make a very, very important impact in that entire journey. And coming forward to this particular key takeaways, as I'm coming closer, I just wanted to emphasize the fact that this particular slide tried to distill everything from the faculty development program in six important principles. First, the foundation first. Tools will change, libraries will evolve, frameworks will deprecate, but fundamentals, the data, learning paradigms, evaluation will remain always the same. Second, the context matters. An algorithm without clinical context is just a mathematics. Ground everything in the real workflows. That is what is critical and important. Third important key takeaway is ethical is integral part, not as an add-on, not as a disclaimer slide. Ethics must live inside every technical discussion when you try to teach. Fourth important thing is interdisciplinary thinking, which is important. Healthcare AI fail when it is done in silos. You need to bring them together to work. It succeeds at the intersections. Fifth is critical thinking. You don't believe in the models directly. You question, ask, teach students to ask questions, predict them, not worship accuracy. And finally, the practical skills. Very important, balance the theory with the hands-on exposure to the real data. If you can internalize these six important principles, I believe this FTP will be successful. The next forwarding sessions also, I believe you should apply the similar kind of a concept. I believe you will be able to make a bigger and bigger impact in that entire journey of thought. So one of the important action which I want to call out for all the people who are attending this, most important, because transformation does not happen through inspiration alone. It happens through the small deliberate actions what you take. I'm not asking you to redesign your entire curriculum tomorrow. I'm asking you to do five important things gradually. First, integrate fundamentals in everything what you teach. Embed AI concepts into existing subjects instead of creating isolated electives. Second, foster the collaborations so that you can encourage joint projects between engineering, medical, and ethics faculty. Third, important, build partnerships so that you can bring local hospitals, labs, and clinics at rich sources of real problems even without sharing the data. Fourth important thing is stay current. AI evolves rapidly. There are new models are coming in. Teaching material must be refreshed regularly, in fact, quarterly or 6 months. And fifth important thing is inspire innovation, not reckless innovation, but responsible innovation, trustworthy innovation. So, as you do this, when you start small, pick one module, improve it in this particular semester, I believe you will change it and it will have a huge impact as we progressively move. Finally, I just want to say that AI will not replace doctors. Doctors who understand AI will replace those who don't. I want to focus on one important element. This treatment is not meant to provoke fear, it is meant to provoke responsibility. AI will not walk into a hospital and replace clinicians, but clinicians who understand AI will make better decisions, work more efficiently, deliver safer care, and those don't they slowly become dependent on tools they don't understand. Now look at the line below. Your role is not to create coders. Your role is to create AI literate healthcare professionals. Professionals who understand probabilities, recognize limitations, ask for the right questions, take responsible outcomes. This is a generational responsibility what you need to really do. When you do that, you are going to make a bigger and bigger impact. So that's what I wanted to touch upon, and I'm open for questions. Forum is open for questions. If you have any questions, I'll be glad to take it up. So I only wanted to discuss on the areas what we really looked at it. I want you to take it with a simple thought process and apply it wherever it is possible. And forum is open for questions. And thank you all. I want to leave you with one important thought. Healthcare is not about uh, technology revolution. It is a human responsibility simplified by technology. Thank you for investing your time, your attention, and your openness in this program. The future of healthcare education does not start in labs or boardrooms. It starts in classroom like yours. And it starts with the choices you make it as your next lecture. Thank you, and I look forward to continuing your journey together. Happy that ASNIST brought this AI and healthcare FDP program onto the table. Thank you, Sujata, for inviting me for this particular talk. Happy that you're taking this forward. And I stop here and invite questions. If there is anything, I'll be glad to answer.
Sir, there are few questions in the chat box, sir.
Okay, let me look at it. Okay. Yeah, what is the question? How to find the good quality data set for lung nodules for classification? Vishal Shitkar is asking it. See, any data set what you are trying to take may have some kind of a noise. Getting a good quality data set is always a challenge, but pick up the things and try to prepare the. That's where I gave you that data pipeline, right? The 8-step process. You need to take it, prepare, validate for the noise, clean that data sets, and move forward. You have the IEEE Data Hub, Data Port, Gov Data as an important channel from the Indian context, and there are multiple data sets which are getting published in the healthcare domain which you can use. Getting a good quality is always a challenge because you need to pick it up, and nobody cleans it for you. You will have some noise, but you need to make the cleansing and taking it forward. Someone was asking. Uh, at which stage we should handle data imbalance? I think Ushasri madam is asking, and how to handle convert imbalance data balanced. I didn't really understand these questions. Techniques for the augmentation of the data. I I request people who have asked Ushasri madam to give some more context to this particular question so that I can answer.
Dear participants, please write your question, rewrite the question in the chat box. Otherwise, you can unmute and ask the question.
Yeah, someone was asking dataset available in Kaggle website can use. Yes, you can use, but again, follow the same 8-step pipeline. And don't believe the dataset which is published blindly. Use that stages so that you will be able to make it happen. Oh, you can get it datasets from the hospitals. Many hospitals are willing to give you the datasets, but they anonymize. They don't give any kind of a patient names. You need to be very cognizant about the privacy of the individual patients. You should anonymize and use those particular datasets. If you are in, I don't know if you are anywhere in the uh, Andhra region, Ramesh Hospitals, Dr. Ramesh is willing to collaborate on the healthcare area, and you can connect with him for any of the cardiology related data set. He has got 30 years of the data set. He wanted to work on the cardiology related problems powered by AI. Cardiovascular diseases, he want to really detect it. Someone was asking Dr. K. Punnam Chandar, asking share insights for CT image data preparation for CNN processing. Uh, uh, Share insights means what kind of insights you're trying to look at, because the CT images will be there for the different parts of the body differently and it need to be interpreted differently. So you need to have the medical ontology and also have the models which are trained to understand whether you are trying to take the CT scan of your body or neck region or the spine region, and accordingly you need to start interpreting. And this CT images with the MRI scans, you need to have the ability to correlate also, because the deeper hidden layers will be able to give us a much better deeper representation. Okay, Ushasri ma'am saying that how do I convert unbalanced data to balanced data? Again, each of the data set will have the labels for the supervised learnings, or you need to have certain weightages which will help you to balance the data. Probably we need to take one particular healthcare example which can give you that kind of a understanding. How do we take care of unbalanced data sets and make it balance? I believe your question is in that particular direction. And if your balanced data sets need to be brought in, let's try to understand some of the specific concepts. So you need to really look at the resampling techniques. Oversampling the minority class with the duplication. So something like a SMOT. Understanding the majority class by removing the data. And you can also use the algorithmic approaches like cause